Hello, my name is Meagan Craddock. This is my Exam 2-2 video on population genetics. I will be demonstrating the effects of inbreeding using magical ponies. On a secret island in the middle of the Pacific Ocean, there lived a species of magical ponies. The island had a total population of 100 ponies. 42 of the ponies were blue and had the genotype of Big A Big A, 46 were green and had the genotype of Big A Little A, and 12 were red and had the genotype of Little A Little A. To determine the allele frequencies, take the number of each specific allele, either big A or little a, and divide that by the total number of alleles. Remember that individuals that are homozygous dominant and homozygous recessive will have the same allele twice and must be accounted for. To determine the genotype frequencies, take the number of individuals who have a specific genotype, either big A, Big A, Little A, or Little A, and divide that by the total number of individuals. The population of ponies is in Hardy-Weinberg equilibrium. The P in the equation is determined by the frequency of the big A allele, which is 0.65, and Q is determined by the frequency of the little a allele, which is 0.35. Plugging those numbers into the equation determines roughly how many individuals in the population has each genotype. The final answer for the Hardy-Weinberg equation is 0.4225 Big A plus 0.455 Big A plus 0.1225 Little A. One day, a big thunderstorm came through the island. Lightning struck one of the trees, causing a huge wildfire. By the time the fire was put out, a large part of the population had been wiped out, causing inbreeding to occur. Inbreeding is the mating of related individuals. It changes the frequency of genotypes, but not allele frequency, and leads to more homozygotes in the population over time. The population is now undergoing a systematic inbreeding scheme. The genotypic array is now determined by p squared plus f times p times q, plus 2 times 1 minus f times p times q, plus q squared plus f times p times q. F is the inbreeding coefficient and alters the Hardy-Weinberg equilibrium to account for inbreeding. It measures the probability that two alleles are identical by descent. Because of inbreeding, the new genotypic array for the pony population is 0.5 Big A plus 0.3 Big A plus 0.2 Little A. To calculate F, you first calculate the frequency of alleles. Inbreeding does not cause a change in allele frequency, so these numbers would be the same as determined by the original population. But if this information was not already given, the frequencies can still be determined by using the equation on the screen. Determining the allele frequencies also determines P and Q. Solve for F by plugging in P and Q into the new genotypic array due to inbreeding. You can use either end of the equation and solve for F using Big A or Big A. Both equations are demonstrated on the screen and result in the same answer. F is equal to 0.3507. This means that there is a 35% chance that the homozygous alleles are from the same ancestor. Genotype frequencies can also be determined by using the new genotypic array. The frequency of Big A is 0.5, the frequency of Big A is 0.3, and the frequency of Little A is 0.2. These are my references. Thank you.